There's a war being fought all around us, and even inside us on a microscopic level. And like in any war, right? The very first step to winning is knowing who your enemy is. So today, we're going to dive into the most fundamental way medicine figures that out.
Purple or pink? I mean, it sounds kind of trivial, doesn't it? But what if I told you that simple color choice could literally save your life? It's one of the most critical questions in all of medicine, because that single distinction, it changes everything about how we fight an infection.
Okay, so let's get right into it. We're going to start with the absolute bedrock technique, the one that doctors and scientists use to sort out these tiny little enemies. And what's crazy is, it's a method that was developed way, way back in 1884, but we still depend on it every single day.
And here's why that's so important. Bacteria, they're not just one big monolithic enemy. Nope, it's this huge, diverse kingdom. Treating them all the same, that'd be like trying to use your house key to unlock your phone. It just won't work. You've got to know exactly what kind of defenses you're up against before you can pick the right weapon to take them down.
And that brings us to something called the Gram stain. It sounds technical, but it's actually a pretty simple test. But don't let that fool you, it is incredibly powerful. This is the test that literally splits the bacterial kingdom right down the middle into two huge groups. It's our first and most critical piece of intel.
So how does it work? Well, you can think of it like a four-step interrogation. First, you hit all the bacteria with this purple dye called crystal violet. Then you add some iodine, which basically acts like a mordant. It helps lock that purple dye in place. Now here comes the most important step, an alcohol wash. This is designed to try and strip that color right out. And for the grand finale, you add a pink counterstain. Anything that lost the purple will now soak up this pink color.
And that's it. That's the moment of truth. At the end of all that, every bacterium on the slide has shown its true colors. If it's still holding on to that deep purple, we call it gram-positive. If it lost the purple and turned pink, that's gram-negative. It's as simple as that. Team purple versus team pink. Okay, but what does that mean, right? It's not just a pretty color. This difference, purple versus pink, it tells us something absolutely fundamental about how these bacteria are built. Specifically, it tells us about their body armor. The secret ingredient here is a stuff called peptidoglycan. It's this tough, mesh-like layer that makes up their cell wall. The best way to think about it is like chainmail armor, and it's the thickness of that chainmail that decides everything. It's what separates Team Purple from Team Pink. All right, check this out. This table breaks it all down. Our gram-positive guys, Team Purple, they have this really, really thick wall of that peptidoglycan. We're talking heavy-duty armor. It just soaks up that purple dye and refuses to let go. Now the gram-negatives, Team Pink, their peptidoglycan wall is super thin. But, and this is a huge but, they have something the positives don't, this extra outer membrane. It's like a force field. And this totally changes how they make us sick, too. The purple ones tend to pump out toxins, called exotoxins, but the pink ones, they have these endotoxins baked right into their outer wall. They only get released when the bacterium dies and breaks apart, which, believe it or not, means that sometimes killing the infection can actually make you feel worse for a bit before you get better. Crazy, right? So now that we know the teams, let's meet some of the players. We're going to run through a little rogues gallery of germs, some of the most famous, or infamous, members of Team Purple and Team Pink. This is where we see how these differences really matter in the real world. All right, let's play detective for a second. A patient comes in and they are not doing well. They have acute endocarditis. That's a really bad infection of the heart valves. They also have osteomyelitis, which is a deep bone infection. And to top it all off, they're showing signs of toxic shock syndrome. So what's the bug? What's the gram-positive baddie behind all this? If you guessed Staphylococcus aureus, or Staph aureus for short, you are absolutely right. It's a classic member of Team Purple. Under the microscope, they look like little clusters of grapes. And here's the thing, this bug can just hang out on our skin, no problem. But if it finds a way inside, it can be absolutely devastating. And get this, some studies show that up to 90% of people working in hospitals can be carrying it, which is why it's such a massive problem in healthcare. Okay, next up, a wool sorter comes in with this very unique, painless black sore, and they're also experiencing severe bleeding inside their chest. Now, that combination of job and symptoms is a classic clue. It points to a very dangerous, spore-forming, gram-positive bug. Any guesses? And the answer is Bacillus anthracis. You know it as the cause of anthrax. And you can see right here in this image, they're shaped like little rods. Another heavy hitter from Team Purple, and its toxins, they are seriously lethal.
Okay, let's switch things up a bit. New scenario, a patient was just hiking out in the northeastern US, and now they've got this very specific looking rash. What famous bug carried by ticks are we thinking of here? Yeah, you know this one. That is the classic bullseye rush. Its fancy name is Erythema chronicum migrans, and it just screams Lyme disease. The culprit is a spiral-shaped bacterium called Borrelia burgdorferi. Now, technically, it's a spirochete and doesn't stain very well with the gram stain, but structurally, it's actually closer to the gram negatives. It just goes to show how diverse bacteria can be. All right, let's turn our attention to Team Pink. This next bug is, well, it's everywhere. It's the #1 cause of UTIs, it's what gives you traveler's diarrhea, and certain strains can cause something called hemolytic uremic syndrome, which is a really, really scary form of kidney failure. So who is this incredibly common gram-negative bug? Of course, we're talking about Escherichia coli, better known as E. coli. It is the textbook example of a gram-negative rod. And it's part of this massive family of bacteria that's responsible for, get this, about 80% of all the gram-negative infections that doctors see. Just think about that, 80%. So, okay, we've got Team Purple, we've got Team Pink, we've met a few of the big names, but let's bring it all home. Why? Why does this simple test from the 1880s still matter so much? Why is it still the foundation of modern medicine? I mean, think about it. We have DNA sequencing now, all this high-tech stuff. So why are we still messing around with some dyes from over a century ago? The answer is beautifully simple. Because it's fast, it's cheap, and it gives you the #1 most important piece of information you need to start treatment. It all comes down to this. The wall dictates the weapon. That thick, heavy armor on the gram-positives, it's the perfect target for antibiotics like penicillin. Penicillin's whole job is to tear down that wall. But try that on a gram-negative, it won't even touch it. The drug can't get past that extra outer membrane. So you have to use completely different antibiotics, ones that are designed to get past that force field. And this, right here, is where things get really serious. There's a quote from the National Library of Medicine that just nails it. Gram-negative bacteria are one of the world's biggest public health problems. Why? Because of their high resistance to antibiotics. Remember that outer membrane we talked about, that force field? It is an incredible shield. It just stops a whole bunch of our antibiotics dead in their tracks before they can even do their job. It's a built-in structural advantage that makes them way harder to kill from the get-go. And on top of that, they're masters of evolution, constantly finding new ways to outsmart our drugs. This is the heart of the antibiotic resistance crisis. So, you see, this great divide, purple versus pink, it's more important now than it has ever been. It literally defines the battlefield. And it leaves us all with a really big critical question. We're in this constant arms race against these bacteria. They're getting smarter, their defenses are getting stronger. So how are we going to stay one step ahead?